In this video, we're going to still talk a little bit more about compressors. The last video on compressors I did gave you a highlight of a couple types, but let's dig a little bit deeper into the different types of compressors that are being used in air conditioning. We have 5 types of compressors. We a little bit have talked about the rotary. We have a screw compressor, we have a scroll compressor, we have centrifugal compressors, and we have reciprocating compressors. Those are our 5 main types. The rotary compressor is usually very small, lightweight. They use blades or vanes to move the refrigerant. It contains an eccentric motor. This means an off-center motor. The rotor rotates inside a cylinder. The suction and discharge ports are open on opposite sides. The dome is on the high side. The first discharge port is connected to a pre-cooler. It allows the refrigerant vapor and the oil vapor to cool. The oil vapor cools at a higher temperature and creates oil droplets. Then we have the first discharge return. The refrigerant leaves the pre-cooler. It returns to the compressor dome as a high pressure, high temperature refrigerant vapor and condensed oil droplets. The second discharge gets refrigerant from the dome and directs the refrigerant to the condenser. The suction line connects directly to the compressor, and there's a process stub that connects to the dome. There are 2 types of rotary compressors. The stationary vane has a blade or vane and a shaft with an off-centric rotor and a discharge valve. The rotary vane or blade has 2 or more sliding vanes. The advantages of a rotary compressor is that the efficiency is much higher than a reciprocating compressor. There's no dead space. It can also pull a deeper vacuum, because there is no dead or unused headspace, and we'll see that more when we talk about the reciprocating compressors. And it's less apt to blow fuses on startups. That rotating motion and the rotary type has a little bit more leniency towards higher pressure and higher pressure differentials. This is how the rotary compressor works. Okay, you have that rotating motor. It pulls refrigerant in from the suction, sends it to the discharge. Okay, there's also a spring internal that you can see on the right picture that puts pressure on the blades or vanes. The rotary compressor usually employs a check valve in the suction side of the compressor to prevent vapor and compressor oil from flowing back to the evaporator. The next type of compressor we're going to talk about is a screw compressor. It's used on large chilled water systems and refrigeration systems. It's available in sizes of 20 tons and higher. They have very little vibration, and they use a pair of special helical rotors, also called screws, to create the compression cycle for the refrigerant. Screw compressors will operate smoothly even when capacity is reduced to as low as 10%. So you have a capacity control capability with screw compressors that actually works efficiently between 10 and 100% of the refrigerant capacity. Capacity control on screw compressors is accomplished by recirculating refrigerant vapor inside the compressor. In other words, we can actually recirculate right inside the hot gas to the high side to the low side without it ever coming out. The refrigerant vapor is drawn into spaces between lobes of the screws. Okay, as the screw gets smaller, the gas is compressed into the condenser. And that's the action you see of the 2 helical screws. Screws compressors come in various types. You have an external or open drive, you have a hermetic, and you have a semi-hermetic variety. Again, very little vibration as it has a continuous pumping action. So, starting one stage of compression as a refrigerant moves through the screw compressor is what this diagram is showing you. You have the inlet where the refrigerant vapor comes in. Then as the screws turn, it moves through the screws into smaller and smaller spaces. until it's compressed into a high pressure vapor on the outlet side of the screws. The next type of compressor we're going to talk about is the scroll compressor. The scroll compressor is the newest type of compressor. It doesn't have any valves. Refrigerant vapor is squeezed, thus increasing pressure. The scroll compressors have very little wear and tear. They only have 3 moving parts. It's 2 offset spiral discs to compress the vapor. And the upper disc is stationary and the lower disc is driven. The driven scroll moves in an orbiting motion. During operation, the vapor is trapped between the scrolls and compressed by the orbiting motion. The scroll compressors can be noisy on startup and shutdown when they're over 3 tons. Some manufacturers have solved this problem by installing a solenoid valve between the suction and discharge lines to equalize the pressures at shutdown. The valve is wired in parallel with the contacts of a single pole contactor. Up until recently, the scroll was only used in systems up to 5 tons. However, this has changed and there are scrolls in most sizes under 20 tons. So the next set of pictures is us disassembling a scroll compressor on a shop bench. Okay, so what we did was basically where this tape is at the top, we took a grinding wheel and opened up a scroll compressor. Pop the top off and the sides off. You can actually see where the motor and the motor windings are down here on the side. And our whole refrigerant compression happens basically in the top portion of the scroll. You lift the top off, you see the stationary part of the scroll, and then you see the rotating part of the scroll. And it isn't really rotating, it's an off-center motor. So if you see how they fit together, you can actually see the 2 sides of the scroll here as they fit together. This shows you once we lift the moving part of the scroll off, you can actually see the drive shaft, which is off-center. So this spins, but where the shaft is, okay, is not in the center. It's sort of in an off-center location. And there you can see the 2 parts of the scroll. And why it's called a scroll compressor is exactly that. So as the rotating part moves in the stationary part, it pulls low pressure refrigerant in from the sides. Okay, and then as the scroll moves, it forces that refrigerant and compresses it into high pressure in the center where the discharge line is. Centrifugal compressors is another type of compressor. It's used in large commercial refrigeration systems. It uses impellers or wheels. They're designed to operate at extremely high speeds. The vapors moved rapidly in a circular path using centrifugal force. Remember, centrifugal force is basically you take a spinning wheel and you put objects into it. That forces the objects to the outside based on the centrifugal force that's created by the spinning wheel. Okay, so the operation of the centrifugal compressors is based on that centrifugal force, outward force. The compression caused by whirling or spinning the mass of vapor refrigerants at high speed. The spinning causes that vapor refrigerant to be thrown outwards. Okay, that spinning refrigerant is then caught in a channel and is compressed by the flow of refrigerant behind it. So here's another picture. We have our inlet line, suction line, that dumps the refrigerant into the center of the spinning wheel. Okay, that is refrigerant is spun at a very high speed. It hits the outlet pipe or the discharge pipe. Okay, that outlet pipe has a check valve in it that doesn't allow the refrigerant to come backwards. Okay, and then the new refrigerant is forced behind it, thus increasing the pressure. In centrifugal compressors, there are no valves. The refrigerant enters through suction inlet and then through suction passages into the first wheel. The refrigerant then enters the wheel through openings near the shaft, as I just showed you. So if we go back here, that refrigerant enters this spinning wheel through openings. The refrigerant is slung outwards. It is then forced through the discharge outlet and then onto the compressor. Lubrication is needed only at the end bearings, therefore centrifugal compressors are mostly oil-free. They do not need any valves or pistons. They operate at very high speeds. Reciprocating compressors are used in domestic and commercial refrigeration units. They are a piston-type compressor. Up until the scroll compressors, these were the most popular compressors that were out there for air conditioning, and now they're still very popular in refrigeration and appliances. A lot of our residential and light commercial air conditioning units are now, and rooftops are now using scroll compressors. The normal RPMs for the older units was 1725 RPMs. The newer units are at 3450 RPMs. These compressors are hermetically sealed. That means that the compressor and motor are sealed in a steel dome. External switching must be provided. You cannot connect directly to the motor windings, and everything has to be done outside the shell. The dome is on the low side of the system. The suction line ends at the steel dome. It fills the dome with a low temperature vapor. Sometimes there's an oil cooler. It's not present in all models. All an oil cooler is an additional loop of pipe going through the crankshaft. It removes heat from the oil. If it's not used on your unit and it's there, just cap the tubes off. The main parts of a reciprocating compressor are the cylinder, the pistons, connecting rods, crankshaft, cylinder head, and valves. For those who understand engines, it's almost like a small automotive engine, except we are not creating energy with this. We are actually using energy. The crankshaft and the connecting rods change the rotating motion of the motor into a reciprocating motion. This reciprocating motion causes an up and down motion on the pistons. When the piston is at the bottom, the suction valve is open. The cylinder fills with a low temperature, low pressure vapor. As the piston travels up, the suction valve closes. The cylinder pressure is greater than the suction pressure. When the piston is at the top, the temperature and pressure has increased. At a predetermined pressure, the discharge valve opens. High temperature, high pressure refrigerant vapor flows to the condenser. There is a dead space between the piston and the valve space. I'll show you that in a minute on a diagram. This dead space is called clearance volume, and this is one of the reasons why reciprocating compressors are not 100% efficient. So as that motor turns in a circular motion, the crankshaft changes it to a reciprocating motion, and the piston goes up and down. So when the piston is at the top, that discharge valve is open. However, this space between the top of the piston and the top of the cylinder, because that piston's not allowed to go up and hit the top of the cylinder, that is called my dead space. That is the reason why reciprocating compressors will never be 100% efficient. It's because of that clearance volume. It's why scroll compressors are considered much more efficient than the reciprocating. Reciprocating compressors are categorized by housing and by drive mechanisms. Housing categories are hermetic, semi-hermetic, and open. Hermetic are fully welded. The motor and compressor are contained inside a single shell that is welded closed. Sometimes in the trade it's referred to as a tin can. You cannot service hermetic compressors without cutting the shell open. These compressors are considered disposable. They are usually cooled with suction vapor. The actual refrigerant cools the compressor. This is an example of a reciprocating compressor. We'll go ahead and take it apart. You have your process stub, you have your suction line, and you have your discharge line. When you pull the top open, you have the motor windings right there in the suction gas. You can take it apart and you can see the valves on the bottom. Okay, so our suction gas hits those motor windings first. That's part of what cools it. You have your valves down here at the bottom. So the next type is the semi-hermetic reciprocating compressor. The motor and compressor are contained inside a single shell that is bolted together. They can be serviced by a technician removing the bolts and opening. The semi-hermetic reciprocating compressor generally uses a splash-type lubricating system in the smaller compressors or a pressure lubricating system on larger compressors, known as an oil pump. They're often air-cooled as well as vapor-cooled. There are fins in the casting, and sometimes there's a fan mounted on the top of the compressor to blow air across it. Sometimes they're water-cooled by use of a water jacket around the compressor. Different applications. This is an example of an air-cooled semi-hermetic compressor. Okay, you have your valve assembly on the top. Your electrical connections are over here on the side, and we'll show you the other side of it where the oil splash is. Sometimes there's spots where you can connect an oil pump to the other side of it. Okay, so we take the bolts out of the top, and then we can pull the valve cover off, and you can see the top of your valves here. When you pull the valves off, you can actually see the pistons down here in the bottom. These are my two pistons. Okay, we'll go to the end of the compressor. We can start removing the bolts here, and we can actually see our motor windings and the oil splash. This is what splashes the oil around to lubricate the compressor. Now there's several types of reciprocating compressors. Okay, they don't always go along with the body types. We have open, we have semi-hermetic, and we have full hermetic. These are the drive types. The open drive type, the compressor and its motors are separate. They're connected by belts or special couplings. This compressor can be serviced or rebuilt in the field. Now, the one thing you have to remember about open drive compressors is they develop leaks at the shaft seal. The shaft seals are used on open drive compressors, and they're designed to prevent refrigerant leaks, but they do leak after a while. The seals use two rubbing surfaces. One surface turns with the crankshaft and is sealed to the shaft with an O-ring. The other is stationary and it's mounted to the shaft housing. The rubbing surface can be made from hardened steel or bronze, ceramic and carbon, Teflon, graphite. And these surfaces have to be lubricated, okay, because they are rubbing together at a high speed and they will create friction. There are four types of shaft seals used: packing gland, stationary unbalanced, diaphragm type, or rotary. Now, the next drive type we're going to talk about that's available is the semi-hermetic. The compressor and the motor are combined in one housing. This compressor can also be serviced in the field, but service is limited. And the third type of drive type is the hermetic. The compressor and motor combined in one housing that is welded closed. This compressor is not serviceable at all. With a reciprocating compressor, there's basically 1 to 16 pistons that can be available, and they're arranged in different patterns. And you can always tell by just looking at where the cylinder is what type of pattern it is. You can have a vertical type with 1 to 3 cylinders. You can have a V type with 2, 4, or 6 cylinders. You can have a W type that's always in multiples of 3. You can have a radial with multiples of 5 cylinders. And you can have an X type with multiples of 4 cylinders. The lifespan and the efficiency of the compressor is based on the maintenance of a system. Dirty condenser coils, improper charges can overheat compressors and raise pressures too high. This will affect both efficiency and lifespan. Multiple compressors can be combined to provide capacity control, meaning when you have additional load, you can use more than one compressor. If you have less load, then you use fewer compressors. This is very frequent in rooftop systems, package units. So to check the valves of a compressor, you can install the gauges on a unit, you bleed the air to the service valves, then jump out the low pressure control, start the compressor, and turn the low side valve in by 2 turns. Read the low side pressure. What that does, it basically opens the service valve to the system. Then you can turn the high side valve in by 2 turns. Read the high side pressure. Front seat the low side valve and read the low side pressure. If 20 inches of vacuum is reached in 2 minutes, the low side valves are good. Don't let the system run forever in a vacuum. Compressors are not designed to run in a vacuum. If 20 inches of vacuum cannot be reached in 2 minutes, the low side valves are bad. Have to replace it. Next, stop the compressor with the low side valve still front seated. Read the low side pressure. It should be in a vacuum. If the pressure remains lower than a 20-inch vacuum, discharge valves are good. If the pressure rises higher than the 20-inch vacuum, then the discharge valves are bad. Replace it. Never front seat the discharge service valve while running. If you front seat the discharge service valve, you're closing off the flow of refrigerant out of the compressor, and you will blow the valves and the pistons in the compressor. To finish up, backseat both valves and remove your gauges. Make sure you remove any jumpers at this point that you added. Lubrication systems on compressors, you basically have 2 types. You have the splash type that I showed you when we just looked at the semi-hermetic that we opened. It uses fingers on a shaft where oil splashes up onto the pistons and shaft. It's used in the older compressors. The other type is forced lubrication. Small systems up to 3 horsepower use the crankshaft and a piston movement to force the oil to the bearings. It's sometimes a combination of fingers on the shaft and the forced lubrication is used. Larger systems, 3 horsepower and above, a pump is mounted on the rear bearing housing. Oil is forced through a machine series of holes to the compressor bearings and connecting rods. The oil pump intake is connected to the compressor's crankshaft, so the oil pump intake is always on the low pressure side of the system. Oil pump intake pressure is always equal to the crankcase pressure, low side pressure. Oil pump outlet pressure is the sum of the crankcase pressure plus the pump pressure. So net oil pressure is equal to the suction pressure subtracted from the oil pump discharge pressure. Oil pump switch works off of the net oil pressure. Okay, so if you have an oil pressure control switch, safety switch, it's going to work off the net oil pressure. Net oil pressure will vary, but it's normally between 30 to 40 psi. And again, net oil pressure is equal to the suction pressure of the refrigerant subtracted from the oil pump discharge pressure. 30 to 40 psi is normal. A bypass valve can be added in case the oil pressure gets too high to keep the pressure under 60 psi. Usually a bypass valve is not adjustable. We don't want that oil pressure getting too high because it can do damage. The other thing we talk about with compressors, and is sort of important, is refrigerant migration. Refrigerant migration means the movement of liquid refrigerant to the compressor crankcase. The presence of liquid refrigerant can affect the operation of the oil pump. Violent foaming on startup results in the loss of oil from the crankcase. The use of crankcase heaters and pump down controls can reduce and stop refrigerant migration during the off cycle. This is especially important in the northeast or northern part of the country, where the cold winters sometimes cause liquid refrigerant to move out of the inside of the system and into the compressor and everything that's on the outside of the system. So we want to make sure liquid refrigerant does not migrate to the compressor. Best way to do this is by use of pump down or crankcase heaters. Crankcase heaters are heaters that go around the bottom of or into the bottom of compressor. All it's designed to do is to keep the refrigerant, the oil in that compressor warm. Warm oil prevents liquid refrigerant from settling in it.